Yeah, we'll go ahead and get started. And where we left off at, we were on chapter 9, which was spanning tree protocol concepts. And we just finished talking about um, rapid STP, so RSTP. And so last but not least, we're going to finish talking about some of the features that are optional to implement within spanning tree that, of course, are used to this day. And in data centers and environments that I've worked in, and I'm sure you guys work in as well, because they're actually utilized with network access control, right, with NAC, and a lot of other network security technologies and what have you. So let's talk about it, right? First one up that we have as far as an optional STP feature is Ether channel, right? Um, One of the best ways to lower spanning trees convergence time is to avoid convergence altogether, right? So what Ether channel does, it provides a way to prevent spanning tree convergence from being needed when only a single port or a cable failure occurs, right? What does that mean, right? So if we're looking, right, if we're looking at this, right, we're looking at our connection of switches, right? From switch one, switch two, right? Switch three, right? We have all that here, right? But we have two connections to each switch, right? This these pair of links, right? Link one and link two, right? If there is a failure on link two, since these links are bundled, right? Bundled has one virtual link. Okay. And what I mean virtual is that this link is configured via software, right? Physically, it's still two different links, but via software, it is one link, right? So this Ether channel, right? Even if one link goes down to the spanning tree, it's going to seem as if the link is still up because the Ether channel is still up because we still have one connection. Okay. Right. Okay. So let's go ahead and erase this. And just like I explained, guys, Ether channel, it combines multiple parallel links of equal speed. This is very important to understand for the exam, right? This is a key topic. Parallel links of equal speed, right? Up to 8 links between the same pair of switches, okay? Bundled into an Ether channel, okay? Now, these are key things, and I'm going to make sure, let me get my pencil again. One, right? Equal speed, right? So speed needs to be the same whenever you're configuring Ether channel. Sorry for my terrible chicken scratch, right? Number two, right? We need to have it's only up to 8 links per Ether channel, okay? And last but not least, right? And this is a concept that also applies to other technologies, is that it's only right? It's only peer to peer, meaning I can't have Ether channel links plugged up, right? Coming from this port, right? Going that's belonging to, let's call this Ether channel one, right? Going Ether channel one links can go here and can go here at one time. It's only a peer to peer relationship per link, right? So all the Ether channel links for Ether channel link one can only go to one peer. Okay. All right. So these are some things that the book doesn't really touch on at this level, at the CCNA level. You'll learn through your labs, but I just wanted to make sure I make it a point because I made that mistake a lot configuring Ether channel, what have you. Um, Again, the switches they are going because again these links, right? These Ether channels, right? They're treated as a single interface, right? In regards to a spanning tree, right? So, like I said, if one link fails, the Ether channel still will be up because one of the links will still be up, right? And since one of the links are still up within the Ether channel, spanning tree convergence doesn't need to occur, right? So the algorithm doesn't need to process. Okay. All right. So we went over that. Check about some more notes, some make sure. And of course, the, the CCNA, right? If you guys look at the objective, they don't touch on, they don't put in here in this section. It's a short section, and I'm going to give you guys some links to look at because it's very important. Um, they don't have in here any key topics within the section in the book regarding Ether Channel, but guys, chapter 10, chapter 18, I want you guys to make sure that you take time to read and to lab, um, because you need to understand Ether Channel has a theory and has a technology, okay, on how to implement it, second nature. Um, okay, so that's Ether Channel. Let's go ahead and move forward and let's talk about the second optional STP technology, which is port fast, right? What is port fast, right? So ports on a switch, right, that connect directly to endpoints, whether it be a phone, whether it be a PC. Um, but mostly we're talking about endpoints that are not other switches, right? That role that the port is going to have is called the designated port role, right? And what state is it going to be in? It's going to be in a forwarding state, right? However, right, with the default port settings, they will go through some steps, right? So if Chris goes ahead and plugs in, right? Let's say, let me get this, right? He plugs this into a switch, right? What's going to happen? Let's talk about these steps that are going to happen, right? After the interface reaches the connected up state, right? So layer one and layer two is taken care of, right? The switch's STP algorithm, right? Or the logic initially places the port in an STP discarding state, right? That's the first state that you guys learned about, right? Then, again, the switch is going to start sending out those BPDUs, all right, out of the port, right? It is going to also listen for incoming BPDUs using multicast, okay? Right? There is a all switch multicast address that switches automatically are embedded in that they are always going to listen to and also going to send out directed to that all switches address, okay? So, again, step two, the switch is going to send out BPDUs and listen for incoming BPDUs. And they're also going to decide whether the switch port should take on a root port role or a designated port role. So it's trying to see, hey, if I'm connected to a switch, is it the root, right? Am I a better, do I have a better BPDU than my neighbor, right? If not, it needs to be a designated port, right? Okay. Because again, it's going to be doing traffic flow. It's not going to be. I don't have to do any spanning tree calculations, right? Step three. Since and just for this picture, since the device that Chris connected, which is just a PC, is not a switch, right? The switch isn't going to go ahead and receive no BPDUs. We know that, right? What's going to happen? Well, what you guys learned throughout this whole chapter, the switch is going to say, hey, this isn't a switch. It's going to go ahead and win the election of becoming a designated port. It's going to become a designated port, right? And it's going to have the designated port role, and the state is going to be in forwarding. Okay. All right. So now that it's done, it's the logic. Now we need to go ahead and transition. We need to get all the way to the forwarding state, right? So, and I hope you realize how much time it's taken me to even explain this in the first place, right? When we're talking about the topic of port fast, right? So when we talk about taking the steps to transition to forwarding state, has a refresher since it's been so long. STP is going to move the port first, if we're talking about regular spanning tree, to the listening state, then the learning state, and then the forwarding state. Each state, 15 seconds, which you guys learned as well, right? It's by default. And again, that's what is that reference to as far as the 15 seconds each? It is the forward delay timer. Okay. RSTP follows the same process, except it doesn't have no listening state, right? So we knock off 15 seconds. Okay. So it goes from discarding, learning to forwarding, right? Now, again, Chris is plugging in, and I want to make sure I reestablish a scenario. If you guys are looking at the screen, he's plugging in a endpoint, not a switch, into the switch that we have in our diagram. Okay. Since it's not a switch, we can implement port fast. What does port fast do? Port fast bypasses the process, right? It bypasses the entire logic. Okay. As if Chris configured port fast on this port, what's going to happen? It's not even going to go through any of this. After the interface reaches the connected state, right? So all the steps that I went through, right? As soon as it hits steps one, port fast immediately is going to move that port into a designated port role. It's not going to go through all of the listening, the learning, the different states. It's not going to go through any of the logic. Automatically put in a designated port role, forwarding state without the delay, right? As long as the interface layer 1 and layer 2 comes up, right? And it remains that way, right? Why does it exist? It exists. Portface was created to support endpoints, phones, servers, PCs, because again, they don't need to go through the logic. So waiting 45 seconds or what have you, right? Right. If we're talking about RSTP, probably 60 seconds, but RSTP lower than that, right? If we're talking about that, that's too long for a PC to come up, right? To the human, not really, but it can be a huge difference, right? If we're connecting a server and we're waiting long for things to process. So port fast was created, helps with with speed, and of course it immediately puts those ports into a forwarding state. Okay. Um, So that is another technology as well. Um, I recommend you guys, if you guys have a real switch, a physical switch, please test that in your lab. It's super cool to see. Um, and of course, even though this is the CCNA, that doesn't mean you guys can't traverse the internet and look for some debugs. See how it looks like within software, right? What's happening. So whenever you implement Ether channel, pop some debugs, and of course, debugs are better with physical hardware. Software, even GNS3, or Docker, it may halt, depending on if you don't have the proper resources. But yeah, go ahead and test all of this so that you can know what's going on, right? I've realized whenever you test all these technologies that you guys been learning about, know what's happening in the background, right? Even if it's seeing what's the process of a link coming up, right? Seeing the debug there for every technology, the spanning tree for layer 1, layer 2, for MAC addresses, seeing how it's learning. You guys learning all that. If you guys learn all that, being able to put it on a piece of paper, you guys will pass your exam, 100%. Okay. All right. Enough of my pedestal. I'm going to hop off that. Let's go ahead and let's talk about this. Another technology, optional STP technology that I love is BPDU guard, right? So we talked about all of the great things with PortFast, right? Right? How it goes immediately from, as long as it's layer 1 and layer 2 comes up, immediately gets assigned a designated port role and sets in a forwarding state. But that creates a vulnerability. It creates the possibility of a forwarding loop if an unexpected switch connects to a port fast, right? If somebody just brings in a switch, right, from home, right, they plug that into a port fast switch. Now your entire spanning tree topology, right, your layer 2 topology, your whole spanning tree is now destroyed, right? How can we fix that, right? Because of course, like it is still listening to BPDUs. Still, even though the port comes up immediately, still listening to BPDUs, right? So how do we combat that? We can combat port fast by, on that same port that we configure port fast, and we know, and if Chris knows, we're going to go back with the old example. If Chris knows it is still going to be a endpoint, he can configure what Cisco created, which is Cisco BPDU guard, right? And what that feature does, it helps defeat all kinds of problems like somebody plugging in a rogue switch, right? By disabling the port if it receives any BPDU. Yes, port fast brings the port up immediately, right? But it still is listening to listening and sending BPDUs. What BPDU guard does, again, if it receives any BPDUs, it is immediately going to disable the port. Okay, so it's handy for your environment if you have endpoints, you have desks, you have cubicles, and somebody maybe, without telling you, right? Hey, I want to plug in this switch. I want more ports on available to me on my desk. Boom. Okay. So learning about BPDU guard, test that as well in your physical environment. It's a cool feature. Please know that for the exam, you may be asked about it. This is a key topic, as you guys can see in the PowerPoint. All right. So let me erase that. I think we're good on time. Let's go ahead. All right. Let's talk about this. So we talked about BPDU guard. Let's talk about another optional spanning tree feature, which is BPDU filter, right? So what this feature does, right? It defines two different functions under one name functions, right? They both fall under BPDU filter because behind the scenes they filter discard spanning tree BPDUs, right? So let's talk about these two features. First, BPDU filter, right? It can be used as an alternative to BPDU guard, right? When used with portfast, right? So what will happen is BPDU guard and BPDU filter prevents loops when unexpected BPDUs arrive on a portfast enabled port, right? However, BPDU filter reacts to those incoming BPDUs by disabling portfast logic, right? Which creates the possibilities of a forwarding loop and restoring the normal spanning tree logic on the port, which prevents the possibility of a forwarding loop. Okay. All right. The other feature, right, is BPDU filter disables spanning tree on the interface altogether. Right. So if it receives a BPDU, it's going to discard all the BPDUs that the interface receives. So the peer that connects to it, right, is going to receive all the BPDUs. Is going to continue to discard, 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 discard. Okay. So if we're looking at group left and group right, they have connections between each other, right? BPDU filters, okay, is set right there, right? Even though they're connected, this is not a redundant topology, okay? With BPDU filter, this is one broadcast. Let me go ahead and clear that out. That looks ugly. This is one broadcast domain. This is one broadcast domain, right? They are not operating in a spanning tree because BPDU filter, right, is configured and they're not accepting BPDUs. So what can't they do? They can't participate in the spanning tree algorithm that you guys learned earlier in the chapter. Okay? All right. Right? Um, Now, most campuses, right, and most enterprise environments, right, they use portfast, right? Even my time at Cisco, they use portfast, right? Their NAC technology, they went ahead and enabled portfast to immediately be configured dynamically whenever NAC does the policy enforcement. Using when it does the policy enforcement, whenever it talks to the policy engine and say, hey, this fits the requirement, configure this port for all these things here. Okay. So portfast is used, right, whenever that is configured. Um, so again, the goal, BPDU filter, it's a stronger BPDU guard. Okay, so just keep that in mind. Please do some labs on it. Please learn about it. pretty cool technology. You will need to know about it for the exam. Okay, so understand that. All right, let's move forward. Okay, let's see. And we're getting to the top of the hour. Let's take a stop here, and then come Sunday, we will go ahead and finish with the last two optional features, which are last two or three, I apologize, with root guard, loop guard, and of course, yeah, loop guard and root guard. Okay. Guys, thank you for attending, and you guys have a great night.
Thank you.